All right. So for those of you who were expecting somebody else to be up here, Anthony Reimer, the person who was originally intended to give this talk, was unavoidably rather, taken up with IT support duties back at our home institution of the University of Calgary. So it's basically been passed to me. My name is Rob Furr, and I am most of your guys' worst nightmare, the interested user. So I'm kind of responsible for getting Anthony into this, so I guess I'm the one responsible for getting him out of it. So what we're going to be talking about today is the lessons that we've learned doing Service Bureau type stuff in a university lab environment for 3D printing. Now, we've learned a fair number of things, and this presentation has been designed to address the ones that we think you guys will be interested in, but really at any time I'm happy to stop and answer questions, receive verbal abuse, discuss, whether or not Hodor actually deserved to die like that. So we will be moving through things fairly quickly, so I understand completely if you want to stop and ask questions about anything along the way. So what we are, Anthony and I both work pretty much in this space right here. This is the media lab, I guess you could call it, at the University of Calgary. We have a lab full of Macintoshes, well, Macs, sorry, you can tell how old I am by the fact that I cannot stop calling them Macintoshes. We have music, we have all sorts of services that happen in this lab, and because of me, one day, we got handed something over and above printing and equipment checkout. Now, I take full responsibility for this because I asked for this. This is an Objet 30 3D printer. It is not the one that I would have chosen if I'd expected that my department would have had to pay for it. It is slightly more expensive than I would like to talk about. And the problem is for us, particularly for Anthony, is that fundamentally this machine here runs pretty much on Windows. In fact, to run this machine, it actually requires two Windows machines, one to prepare files and one to actually be tucked away inside it. And not only inside it, but happy, happy, joy, joy, it is actually running Windows XP. So you can imagine the headache that this caused Anthony, who is a fairly dedicated, I want nothing but Mac OS. That's what we're calling it now, right? Right, okay. Mac OS in my lab. So just the simple lessons of integrating the 3D pipeline that depends pretty much entirely on Windows-based software was fairly challenging for Anthony, and we've learned a few things while we're doing. Actually, let me just turn this off real quick. No, I don't want that. Stop that. There we go. So here's the thing that I pretty much learned asking for this, and Anthony learned when I did ask for this, which is the powers that be think 3D printing is pretty neat. That it's really, really cool and really, really awesome, and it's the wave of the future, and everybody is going to be able to want to walk up to a machine and say tea Earl Grey hot at some point. I can tell who's the real nerds in here. And get a printed out cup. You guys may very well walk into this situation, or you will shortly. 3D printing is the new hotness, and so we need to address it. Now, there are a whole bunch of questions that most of you have, and we tried to figure out the ones that we need to talk you through. Now, these are going to be broken down into what you can get out of 3D printing. That's the thing that most of you are probably going to, when the powers that be above you come to you and say, we want to do 3D printing, the most fundamental thing that you need to be able to come back to them with is, are you sure you want this? Because they think it's going to be like Star Trek. They think it's going to be like you ask for a I don't know, car or something, and you get a car. It doesn't work like that. The next, we're going to talk about the hardware options that you have, the software that you have, and the things you need to know about the files that you will be getting. So, because I don't really have a joke for any of that, we're just moving straight on. So, output. Now, the first thing that you got to know is that there are several technologies, all of which come under the name of 3D printing. There's resin, there's filament, and there's what's called subtractive 3D printing, or, well, subtractive 3D output, CNC machining, et cetera, et cetera, et cetera. Basically, you can either get the thing, the stuff that comes out in a liquid, in a solid, or you can get a drill and carve it away. Now, the easiest of these to talk about is the drilling. It's also the longest and oldest version of this, and some of you may have actually seen this being offered for sale through, among other things, Studio Neat, which make, among other things, little clips that you can use to put an iPhone onto a tripod. And about a year ago, they offered something else, a nice little stand for your new Apple TV remote, that they were very proud about, that they used subtractive modeling on, or subtractive 3D printing, or carving, or whatever you want to call it. It's usually referred to as CNC machining, computer numeric controlled machining. And essentially, what it is a drill attached to a computer. So it carves it away. Here's the thing. What do you get when you start carving away wood or metal or whatever? You get sawdust. And it's loud and it's annoying. And currently, the CNC machines that are easily available are 2.5D machines. That means that the drill bit never rotates from this axis. It goes left, right, forward, and back, and up and down. That's the half D, but it doesn't go underneath things. So it can carve reliefs, it can carve surfaces, but it can't really do an entire three-dimensional model. But the key thing for us is that it is basically a wood shop issue. You need drill bit, you need a drill, you need a thing that will handle the sawdust. In many cases, according to laboratory safety guidelines and OSHA, you need something that will vent the keep the sawdust from getting into the atmosphere, et cetera. So we are not going to talk about this too much, because while the software and the files are all very, very, very much part of the overall 3D printing pipeline, it is, however, so much of a headache that if anybody comes to you and asks you, I want to get a CNC machine, you want to run away screaming. Not because it's that hard to do, but because of the materiality of it. Sawdust is just a pain in the butt according to the legal standards. So if you don't want to get into that, just say, can't the guys over in engineering do it? Can't the guys in the wood shop do it? You don't want to, I mean, who wants sawdust in their Macs? I don't. What we traditionally deal with in 3D printing is additives. The CNC machines carve stuff away. What we like doing is adding stuff. I generally, to my classes, refer to this as these devices as basically being the hot glue guns from hell. And some of them really, really are. In fact, this thing right here, which stopped working for some strange reason. If it had been working, it would have cheerfully been squirting away plastic while we were talking. Basically, you have what's known as fused deposition modeling, which is the trademarked term, or what we in the hobbyist community call it, fused filament fabrication. The fused filament fabrication is the stuff that has gotten the big amount of noise in the press these days because the patents have fairly recently expired. So hobbyists can now get in to start making these things. The maker community is really, really big on this. And I can pass this around if you guys are interested. But fundamentally, this stuff here, you melt it, you squirt it into shapes. Operating a fused filament printer is kind of like being a contestant on Cake Boss or something, where you're building things out of fondant or something, or however you pronounce it. The other alternative, in most cases, is UV cured resin. It's basically a form of epoxy kind of stuff that you expose to light and it hardens up. Both of these have advantages, both of these have disadvantages. Both of them are things that your superiors or the people who are telling you that you need to support 3D printing need to know about before they just say, here, buy one. So, this thing right here. This is a sped up image, and I would, if this thing was still running, I don't know why it stopped, but this is a sped up image of a fused filament 3D printer working. As you can see, it too only moves left and right and up and down, but because it's building up, it can do, to a certain extent, what we call undercuts. This is a hyperboloid vase, I don't know, being built up, and you can see right up here those little parts of it leaning over. Now that little part leaning over is one of the great things about 3D printing as opposed to CNC machining, but it's also one of the problems. We will talk about that problem shortly. Here's a slightly better video of it where you can see that what this looks like as it's printing the overall vase. Now, let me just assure you, this is not real time. This is very far from real time. In fact, in a bit, I'm going to show you something that me and Anthony watched about 3-4 days ago that pretty much made us just go, ah, because it was in real time. But the problem with this is, because you're building up with no particular magical anti-gravity, anything that overhangs too much is going to do what we call drooping. I would pass this around, but I forgot it because I'm an idiot. Just imagine you're building these shapes up layer by layer. When you get to the chin, right here, and you see the little dimple on Yoda's chin, right here, this thing, there's a little gap right here. But if you print this the way 3D printers normally work, or fused filament 3D printers normally work, you'd go print, 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 and then it'd stop printing, and it'd print up, start right there again. The problem with that, if that cone wasn't there, that chin would be hovering in space. Even if it was horizontal, squirting out hot, droopy plastic into midair never works very well. So what we in the hobbyist community is, we like to print things that don't have significant horizontal overhangs. Now, your fused filament printer can do something called bridging. Bridging is the idea where you take your hot glue gun that's squirting out the plastic to do this, and you just rev it up, its speed up really, really fast, and just go, wow, boom, and try and get across the gap as fast as possible, keeping the plastic taut while you do it. Ask me how well this works, and I will laugh and laugh and laugh and laugh. The best thing to do whenever you have overhangs like that is orient your model so you don't have an overhang. For instance, Yoda here, if he had a completely flat back right here, this would be fine. Well, maybe from his ears or whatever, we could rotate Yoda and build up from his back, and then the chin would just be vertical instead of horizontal. Fused filament printers basically can go about the angle of Yoda's ears. That's about as steep as they go. The other thing about that is they do droop, and if I had, again, brought it out, you could be feeling it right now. The fused filament printers, unless you spend an astonishing amount of time, they're squirting out 0.2 micron, I think. I had a late night. Airplanes, whatever. A very thin 0.2 millimeter layer of plastic, which pretty much means that they're not smooth. Because what tends to happen is that you squirt out plastic and it bulges out. So every time you print something, it bulges out, then the next layer bulges out on top of that, and the next layer bulges out on top of that. So in addition to the drooping problem, you also get the fact that fused filament printers are actually, have you guys ever run your fingernails over an old vinyl record? It feels like that. It's scritchy. Now, if you use the right plastic, you can polish that off by slinging your model into a chamber filled with like hot acetone vapor or something like that. But your easiest plastics to print with don't really print like that. So the cheap printers that everybody's very excited about are going to generate some amazing things, but they're all going to feel like records. They're all going to be bumpy and scratchy. Could you use them as parts in a machine? Yes. Would you want to print a piston? Probably not. Anywhere where the parts have to slide against each other, they're going to work, but they're not going to work so well. So let me illustrate the overhang problem. Now this right here is just a representative 3D model that you might be asked to print. It's a sphere. I know, you're shocked at this revelation. But the thing is that at some point, you could print this one layer of pixels right here at the very bottom, but the instant you go up one, it's got so little supporting it that this is a steeper angle than Yoda's ears. So what you'd get is, you'd get the next one and sort of droop. Now they do make little blue pills that help with that. Okay, some of you are that age. Some of you aren't. But in general, it's a pain in the butt. Like CNC machining, the guaranteed way to make a fused filament printer happy is have no overhangs. So quite frequently what you will be, what would be a better solution if you were going to be asked to print this is you'd slice it in half so that it piles up, so that there's no unsupported angle, that everything is the other way. And why do I suddenly feel like I'm doing YMCA? I don't know. Anyway, so this right here is our biggest issue on fused filament printers though. They're also somewhat annoying to operate because they do require a significant amount of fiddling. And in point of fact, I might as well just go straight to this. Your average fused filament printer, the duration it takes to print is basically proportional to the amount of plastic. So if you print something solid and use a lot of material, that's going to take a lot of time. You print something hollow, and you can sort of see that here, except it stopped, and it'll take less time. This gives you a lot of options in how strong you want to make something, how flexible you want to make something, etc. But at the same time, if you do want something very, very solid, it's going to be very, very long. Cool thing about fused filament printers is as long as you can melt it, you can print with it. I personally have a printer that will print in wood. You can get filament that has carbon fibers already in it, so it's as strong as steel. You can print surgical grade nylon, although let me just share with you, the surgical grade nylon is annoying as heck to print. It's very persnickety, but you can do it, and it's very strong. You can print floppy, you can print bendy, you can print whatever you want. If it melts, you can print it. I have eaten a 3D printed goat cheese and apricot jelly snack. It worked just fine. You can buy 3D printers for chocolate. If it melts, if it melts and you can cool it back to solid, you can print it. Makes for some wonderful things. And when I say wood, I'm not kidding. What they do is it's the same stuff as MDF. You put like cherry sawdust in a meltable resin, squirt it through your fused filament printer. We're not kidding, that's cherry wood. Works really, really well. Angle, we've already talked about. Some designs just are too much of a pain in the butt to print. There we go, 0.1 millimeter is about, I've actually managed to get one of my printers doing that. It took me about 20 hours of calibration, because I built my own printer and I'm terrible at it, so it took me a long time to calibrate it properly. So it's not going to be as accurate as you need for many applications. The cool thing about this is that you can get these printers for incredibly cheap. You can get 3D printers for about $200. Let me just assure you that you do not want a 3D printer for $200. Because the cheaper it is, the more it asks you to do. One of the things that we'll talk about in a bit, but I'll just tell you right now, is that 3D printers are very persnickety about being level. Because you've got a hot glue gun. And if your glue gun is squirting out, you don't want the thing printing so the glue sort of slides down. And also you don't want it to have the print head running into previously printed glue so it smears it, or printing into space where it drops down and cools so you get separation. So they're very persnickety. The cheapest that I personally would go at for right now in a fused filament printer is probably the $800 mark. At the $800 mark, you can get something that will automatically level its own print bed and behave reasonably well without supervision. If you really want to print and walk away, I would aim at somewhere around the $2,000 or $3,000 mark. The alternative to fused filament is the resin, or as our machine refers to it as PolyJet material. Resin lets you go way smaller. Basically, it works pretty much like an inkjet printer. You spray out the material, you expose it to ultraviolet light, it hardens. You spray out more material, you expose it to ultraviolet light, it hardens. You can get incredibly fine, smooth, thin prints out of this. It's really amazing. The good ones, the great thing about this is the cheapest one of these that I would recommend is that it's about $10,000. I have theoretically, this kind of printer should be incredibly easy to make because all you're doing is exposing material to light. Well, this surface right here is being exposed to light, isn't it? Right where my hand isn't getting exposed to much light. Up there under the letters, that's being exposed to a lot of light. So these kind of printers, some of them, you should be able to just shine a light at a tank of this stuff and have it harden, or a projector. In fact, there is one of these that has just been kickstarted that I should be receiving in about a month that uses your cell phone as your display surface. These are annoying to work with, and you want to run screaming away from them because they are somewhat unpredictable. The good ones are still, of that kind, are still up in about the $30,000 plus, all the way up to $200,000 mark. The alternative is, as I said before, the inkjet version, where you spray out little bits of plastic and overlay it. Now, let's go back to this. Support material is the key word here. Your average resin printer, because it's not squirting out like a pen, it's just going and spraying out, actually has the capability of spraying out more than one material at a pass. So one of the things that printers like this can do is fill in the overhang with something that breaks away. It's called support material. Now, your fused filament printers theoretically can do this. I have never yet successfully managed it. They always tip over and fail, and it just never works. So support material, it's like the styrofoam packaging around your personal electronics. It can't fall down if there's something underneath it. Typically speaking, this material here is cheaper than the print material. It breaks away on the Objet 30 that we have. It is one of those things that you really hate touching it because it's just creepy feeling, but you really do get a much greater flexibility in your print. This is our printer right here, just somebody else doing it. And you can just see an entire print head just goes sweeping across the print field, spraying down either the plastic or the support material. This right here is pure support material. It's laying down what's known as a raft or a bed, so it comes off the tray very easily. This is a time lapse, and you can see there's the support material. Now we start building the tags on top of it. You can see the different material coming in. And there you go. Advantages of this: you don't have to worry about whether or not it will print. Generally speaking, if it's what's called manifold or has a seamless surface, anything you want to do to print can be printed by one of these printers. Problem is, they cost more, and oh my God, the material costs a lot. This right here is ridiculously overpriced at about $40 per one of these. A equivalent tank of resin for our printer is about $600. Commercial price. There's an educational price, but I have no memory of what it is. I think it's about half that, so $300. So that's what you have to be able to tell your bosses when do they want the cheapness of this, and are they willing to put up with the limitations? It takes for bloody ever. It's not going to be as sharp as you like. You have to jump through several hoops to make sure it prints, but it's cheap, 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 and, well, you know, you can have a lot of flexibility. Or do you want to guarantee that something will print, but you want to pay the money? Now, the other thing about these printers, the one is, the resin printers, the patents are still in force, so they are still expensive. If you want one of the printers that can actually print like children's toys, you just press a button and it will print out something with rubber tires and clear windshield and all that kind of stuff. Those start around $90, I think, still, $90,000. The one that we have can print 4 materials plus support material, I believe, and it cost us $30. We have another printer like it in the building that can print count 'em, one material plus support material, and it cost about $12,000. It's a lot smoother. They always print solid objects, by the way. They don't have the capability of making things lighter very much, because when you're doing little dots of plastic being applied down, you have to just, it's like Lego. It has to be solid building up. The squirty plastic kind can do whatever inside. These tend to have to be solid. Here's the fun part about it, though. You waste a lot of material printing, and unfortunately that waste is toxic waste. It is hazardous. It has fairly aggressive solvents in it. So when you're printing with this, you waste a fair amount of material, and if you leave your printer on board for a while, the plastic inside the acetone or whatever solvent they're using separates, and you get solid plastic on the bottom of your tubes and solvent on the top, which means you have to call the manufacturer and they'll send out somebody for the low, low price of $10,000 to fix it. I'm pulling a number out of air. I have honestly no idea. These things, you leave them alone, they don't care. As long as it melts, you're good. These, Anthony has to spend about 5 hours a week just keeping ours working. Well, these days it's probably more like 2, but originally he was saying it was like 5. Now, there is an up-and-coming technology that I am going to show you. Hello? Yeah. Where are you? Oh, bite me. Oh, it's jammed. Okay. Cancel. Cancel. Go away. I hate you. Yeah. Come on, I just want, here we go. This is the kind of printer, as soon as it comes up, this is the kind of printer that I was telling you guys is the one that should be really easy to work. Oh, where are you? Here we go. So this thing right here, this is one of those, this is the oldest and yet the still most up-and-coming printer technology that you're going to get. Basically, you shine an intense light onto a tank full of liquid, and you can do this. This is real time. Guess how much this costs? $250,000. Yeah. Here's the thing, it's awesome, and actually these guys are really, if you print a lot, this actually makes a fair amount of financial sense because their resin costs are $150 for a tank compared to the $300, $350, $600 that the object guys print. So, uh-oh, Keynote went away. Why did Keynote go away? Why does it hate me? Yeah. Come on. There we go. So, cost is another thing that you're going to have to come up with a way to break to your superiors when they want to do this. Cheap is fine, but there are limitations. Medium at cost is fine. There are limitations. Transporter grade technology is great if you have $250,000. So, let's talk a little bit about the hardware. Now, you can buy commercial fused filament printers, as we said. We've got one here. Here are a couple of them. MakerBot is by far not the only manufacturer, no matter what people say. So if somebody comes up to you and says, we want to buy a MakerBot, you might want to say, okay, what do you really want to do? Because the MakerBot's print are kind of restricted to one kind of filament, and they're really trying to make it so you have to buy their filament from them. So they're making fairly proprietary reels that fit in their machines only, etc. So you might want to ask about what the person really wants to achieve. So this thing right here is what we refer to as the build tray. Whenever we're talking about printing, we're always going to be talking about the tray. The tray is the thing that has to be level. The tray is where the objects go. The tray is everything that we want to deal with. Now, that stuff we already showed you is the filament. It goes right there. It gets melted. As opposed to this, which, well, to be honest, we already saw that, so, you know. Here's the interesting thing, though. This would be incredibly inefficient to print in this orientation for the support material reason that we talked about before. Typically, when you're printing these things, you do not want to have your Chinese dragon model with its belly that far up off the ground because you'd spend all the money in the world filling in that loop. Also, your average resin-based inkjet printer model, the time on that is not amount of material. Length of printing for a fused filament, it's how much material it is. This, it's how many passes it takes to build up because it goes and it has to reset, move up, etc., and then go that again. So whenever you can on these machines, this would probably take about 20 hours to print in this orientation. It might take as little as 2 if you laid it on its side. And it would certainly cost less. Every time you go, that's constant. No matter how much or how little material there is on the tray, it's going to take the same amount of time to go across the tray. So the more material you can put onto each one of those passes, the faster it goes. Does that make any sense at all? Anthony's the one who usually does this bit. Okay, we've given this talk before. Anthony handles this printer. I am scared of this printer. It smells bad, it makes scary noises, I run away. So there's the build tray, there's the clear material, etc. Now, here's the thing about this. Because for the resin-based printers, the speed of printing is constant on horizontal space. These are actually designed to print multiple objects on the same build tray. Typically speaking, in our department, we wait until we've got like 5 or 6 or 8 or 10 different things to print before we do a print job because it's just that much faster. If it takes 2 hours for one person to print because it's 2 layers, it's 2 hours to do the up, we might as well take 2 hours to do 40 people's little things and take 2 hours to do it. On the other hand, you do have to print every week or it gets jammed with solid plastic and then the guys have to come out and they pity you. They look at you and they go, and then we have to kill them and bury them in the Las Vegas desert, and it's just a bad scene all around. These, this is the Form 2. This is the slower junior version of that one that I showed you, the Carbon 3D. It basically works like we showed it. It's got a tank of resin. It gets pulled out. This one, again, it's going to be one model per print, but it is going to be pretty much determined entirely by z-axis or height of the model. I don't care how big or small it is, horizontally or back and forth from you, but it's going to take purely based on how tall it is. So there you go, build area, resin cartridges, etc. So when you're setting this thing up, as we've said before, first thing you got to worry about, can you put it in a level space? Odds are if you're out in the Alberta wilderness working in the oil patch, you ain't going to have one of these. Most of you guys, I assume, have a level table somewhere to put these on. But that's the first thing. These things also are fairly sensitive to vibration, so you need to have a reasonably firm table. And by reasonably firm, I kind of mean 3-year-old resistant. If a 3-year-old can shake it, you don't want it. So if you have 3-year-olds, that's kind of handy. Another thing, these things smell. Now, some of them smell worse than others. The resin-based printers that you saw, the Objet 30 and many of the other ones, actually are enclosed. That's why they have that big solid lid so that the air doesn't get out. They actually exhaust and condense their vapors and dump it out as toxic waste. But even the fused filament printers emit hazardous materials. Now, you might notice that you don't really smell anything here. One, because it didn't print that much, but two, what's called PLA plastic isn't that dangerous. But the current thinking is that your fused filament printer does not generate a lot of hazardous odors, although it is enough to give Anthony a headache if he's around one for much. He's fairly sensitive. But also because whenever you squirt plastic out, to make sure that you don't get extra, it always squirts a little back in. I mean, sucks it back in every time it needs to stop. And every time it sucks it back in, the surface of the hot glue is cooled down a little bit, and it scrapes a little of that plastic off. And that plastic is little teeny tiny. And it's so little teeny tiny that it can be affected by Brownian motion, and basically we're back to the sawdust problem again. So you want to have air handling capable of getting rid of that stuff. You do not want to be breathing. Just like the popcorn factory workers, we do not want to see you guys in 30 years having 3D printer's disease. So there's a reason why, one reason why this printer here has these plastic gates on them. One of them is so that the air is kept still, because you don't want to have air blowing past a fuse to cool it off. Another is so that little inquiring hands don't stick their hands in there to get burned by the 200 degrees Celsius, 240 degrees Celsius burn, squirty bit. But also you want to keep this fairly protected from the outside environment, which raises the question of why this thing doesn't have a lid right now. Why doesn't this thing have? I don't know. But generally speaking, what we do for our fused filament printers at the University of Calgary is we have several of them, and we built a dedicated enclosed environment where we can actually hook up a vacuum cleaner and suck the air out and dump it through a HEPA filter before we open the enclosed environment. Not because this is regulation, but because we think it's better to be safe than sorry. Other thing is, depending on the model, these things can be somewhat noisy. I was hoping to have this thing printing during my talk so I could have to shout over them, but the thing is they are noisy. The cheaper they are, the noisier they are. I have one called a Delta Maker, which is a lovely, indestructible, bulletproof, very pretty, made for open public display printer. And the thing is so noisy, it goes all bloody day long. Because again, these things take 4 to 6 hours. That Yoda that we showed you there before, at about this size, is usually about a 6-hour print. You can go faster, but not that much faster with a fused filament printer. As we've said before with these, the cheaper the printer, the more noise you're likely to get, the more you've got to add your own air handling and temperature management, and the more you have to be a hacker. These things come out of the maker community, and as we were talking about before I got started, a lot of the people who make the cheap ones think that it's no fun if you can't go in and poke at things. These are the people who think that running not even Windows, but Linux is worth it, okay? We are not that kind of people. We are Mac users. We want to have the controls that are necessary exposed unless we absolutely need them. So a lot of these printers are designed by people for whom the need to go in and twiddle is paramount. That makes your life a little bit more annoying. So again, the more you can get your superior to spend, the easier your life is going to be. I hate to boil it down to that, but it's true. Now, operating consideration, again, I've referred to this over and over again, but a lot of people are still affected by Star Trek style considerations. His t-shirt is a good visual reference, but I'm not going to make him stand. I'm just going to draw attention to him so everybody stares. Anyway, sorry, but the Star Trek idea, people think that you can just say, oh, we're getting a 3D printer, and then you can just say, oh, you print a new keyboard, print a new screwdriver, and you've got to say, well, somebody's got to design the model, somebody's got to make sure it can print, somebody has got to make sure that it is worth it, because again, Yoda, 6 hours, 8 hours. Something as small as little name badges like this might this thin might take you 20 minutes to print. These things are not yet that fast. If you want speed, that's why we like CNC machines. A CNC machine can cut out things a lot quicker than a equivalent 3D printer usually can print them, because drills just drill. And the stuff they're printing is usually solid. And the maintenance is non-zero, just keeping one of these things running. Our library at the University of Calgary had a replicator of this generation right here, a slightly larger one, that they said, hey, we're going to let people just come up and print whatever they want to, and we'll just charge them the plastic, and it lasted about 6 months. Because it just took, the more you run one of these, the more maintenance it's got to do, and the more maintenance, the less it's printing. And so if you're going to have this be a key part of your operations, you've got to schedule time for it. And again, the more time, the more money, fewer headaches. Now, we've talked about why you probably don't want one of the hobbyist grade printers just because they expose the controls that you don't necessarily need. That right there is a Prusa from the RepRap lineage of 3D printers. You can buy all of the parts to make that for about $99. The most expensive thing in a 3D printer in general is going to be those little motors there at the corner. However, building it took me about, not this one, mine looks much, much worse. Building it took me about 40 hours, and after a while I got so frustrated with it, I literally threw it out the window. I am not kidding. I was that frustrated. So your decision is going to be, you have to tell your boss or whoever's saying we want to do this, what do you want to do? Do you want to make art? Do you want to make something that is organic, that is lumpy, that is has lots of overhangs, or does it have to be a mechanically functioning part, or whatever? And then you have to decide, okay, if you want to make something that just looks cool, fused filament's fine. If you want to modify it, it's fine. But if it's got to be a part in a machine, you want a resin printer, okay? But the resin printer materials are frequently fragile. Okay, you might want to go for one of the more expensive ones. Well, do you have $50,000? You need to be thinking about what the application is, because 3D printers, this is not like a printer, 2D print, paper printer, where you put paper in, stuff appears on the paper. The task matters. Now, just because I'm talking a little bit longer than I want to, the software pipeline for these sorts of things, because these are hobbyists, or a lot of it comes from hobbyists, there is a huge amount of open source and free software that can help you with this. So the software is not really that much of a concern. It's a little bit annoying. Here's a few that we use at our our lab. My personal favorite application to give people who just want to go, ooh, 3D printing, is that one up there. It's called Sculptress. It's ZBrush's junior brother. It makes files that 3D print phenomenally well. It's free, and it lets you make Gollum in point of fact. I mean, honestly, in the special effects community, a significant portion of the characters that you see every day got their start in Sculptress rather than any other program, just because it's fun, free, and a really fast way to work. If you want to do more wood shop, more geometric type stuff building, Blender is quite powerful and quite good. It has a lot of features that you do not need to do 3D printing, but it's very, very nice. Others, ZBrush, Cinema 4D, Vectorworks. Autodesk has a lot of applications that are free for academic use that will 3D print perfectly well. The one of these that I really think that you cannot get away with is the one that I haven't talked about right here, which is MeshLab. MeshLab, if you do not have, I don't care what you do. I don't care who you are. If you are somebody running a lab, MeshLab is necessary for you at some point in your life. It is the moral equivalent of Photoshop in that it will open anything and save it to anything. It's just this time it's 3D. It also does a fair amount of repair work on your files. It's free. It's readily available for every operating system known to man and a few that aren't. And we could not live without it. It, by the way, makes very nice stereolithography files, STL. Pretty much every 3D printer in the world will print an STL file. This is the moral equivalent of like a JPEG. To print an STL file, you have to turn it into what's called the tool path, which every printer has its own particular way of telling it where to go and what to do with its print head and whatever. But STL is the definitive intermediate file format, and MeshLab makes lovely, perfectly tidy, nice STL files. Some 3D printers, like MakerBot, will print straight from what's known as OBJ, Wavefront's old file format from the 70s. If you cannot get to, somebody gives you an OBJ and your printer can't handle it, that's what MeshLab's for. But OBJ is also, I mean, it's out of copyright, it's out of patent. Every 3D program on the planet, if it knows what's good for it, can output OBJ. And once you can get to OBJ, MeshLab can get you to STL. Now, some programs can output straight to STL themselves. From personal experience, I still prefer to go through MeshLab, and I will tell you why, because I use a 3D program called Modo, which, for those of you who have ever seen Firefly or Star Trek Voyager, that was that program. The problem is Modo's STL support is so bad that it hurts the baby Jesus. So I would much rather throw it to OBJ and output it that way than suffer through what Modo does to STL. Other programs, I have been told Cinema 4D, it generates lovely STL, but at some point you're going to be doing file conversion. And so MeshLab is pretty much, if you do not have it, you are wrong, you are a bad, bad person. Now, depending on how much you spend on your 3D printer, you will get a certain amount of software. The $30,000 Objet 3D that we have came with its own what's called slicing software. That means slicing, we talked about how when you print in layers. Well, you got to take the 3D object and slice it into layers. And every 3D printer does it slightly differently, and the more you spend on it, the more likely it is to get the software that does it, particularly for that printer. So The cool thing about the Objet 30 is that allows you to do some very cool things like assembling a tray with multiple objects on it. The weird thing about it, we actually bought a separate Windows PC to go with this. The weird thing about it is that we bought a fairly low-end, I admit, fairly low-end PC to run it, but the cool thing is that their software actually runs better on a VM on a Mac than it does on the Windows machine. So what Anthony will do is he will actually prepare the whole tray, the file, slice everything, make it capable of being sent to the printer on his desktop machine, save out that file, walk into the machine, and the only thing he has to do on the Windows machine is just send it to the Windows machine inside the box. So slicing is a step that is fairly necessary, but it is also usually fairly brain dead. So you don't have to worry about doing it very much at all. This is what it looks like, and you can, okay, went too far. This is what a tray looks like, and you can see each one of these strips is one pass of the print head. So you can see that this thing, to print the whole stage, does 3 passes. So it actually depends how far along that way, not very much, but definitely how far up it goes in terms of print size. Oh, good heavens, I got to talk a lot faster, don't I? So when you're assembling a tray of stuff, quite often 3D files are not printable. They have problems, they have errors. So your first task whenever you're doing this, and it is a time-consuming one, is to make sure that it can be printed. So you take your files, you open the software in a VM or whatever, make sure it's the right size. This is the other problem with Modo. It generates files that the 3D printer thinks is 1/1000th this big. So when I ask for something this big, it prints it this big. So I always have to scale it up. Very annoying. You have to scale it, you have to make sure that it's positioned on the tray so it can print, and then you have to verify. And our software, the one for the Objet 30, will actually tell you how much material it thinks it'll take. It'll usually be plus or minus like 2 or 3%. And then you can save the tray and send it on over. Couple of the problems is that models are frequently made by students. And students frequently don't know what they're doing. So if something cannot exist in the real world, such as a single flat polygon with 4 sides where polygons have to be flat. And if you have a 4-sided polygon that unfortunately all the points are not flat on the same plane, your 3D printer is going to go, this makes no sense, and refuse to print it. You have to do some other things. To make sure. Here's 3 different models. No matter how we reorient this thing, if somebody comes to you and says, I need this printed, and you've got a boat, a hat, and a chainsaw or whatever, but they're in the file like this one's going to need a lot of support material because it's hovering up in the middle of space. So you got to yell at the student and say, I'd really rather them come in 3 separate files so I can put them on the tray the most optimum way for me. Anthony usually looks very pained at this moment because no student ever does. So laying it out, you have to insist on it being your responsibility, but that adds time to your day. Now, there's another lovely program that is the one that we use, but I don't want to recommend it to the same extent that MeshLab does because there are other options. NetFab is not the only one of these, it's just the one that we use. And the reason why we use it is Microsoft offers a really lovely online version of it that you can just throw a broken file at on their Azure cloud system, and it'll clean it up and fix it and make it all pretty and work and triple all the polygons, make them into triangles. What I mean by tripling. But if you want to do it locally, they do give you a very basic free version of their program that allows you to split files up and make them into separate chunks and relay them out and do all sorts of other stuff. It is for free. It is a little challenging to use, but what are you going to do? So you verify the tray. You make sure it has no holes in it. You make sure that it has no triangles, polygons passing through each other. Your 3D printer has to know what's inside and what's outside. And that's actually surprisingly complicated. So these are your options here that we consider. Free is the one that we use. We've considered buying NetFab Private, but it is a lab, so we would need to get the professional version. And the professional version, we've asked for a quote, and it was so painful that I don't even want to put it on the board. It was very, very, very bad. But basically, you don't want to have to go into your 3D modeling program and fix it by hand. You want a computer to do it. So, and if it can't, then you tell the client to go away and fix it themselves. One of the common problems that we have is somebody comes in and asks for, on a printer this big, a file that needs to be this big. Can't be done. A lot of times you just have to say it won't fit on the printer, or you have to slice it into parts like Lego or something like that. You can scale it. A lot of your software can do that. You can split it, you can chainsaw it, or you can reorient it to fit it into the space. But again, that takes time. We sort of already talked about that, didn't we? Oh well. So models, we already talked about that. All right, boy, I skipped ahead, didn't I? All right, Autodesk 123D offers some lovely free apps. It's not a start to finish solution by any means, but if you want to do some interesting things, consulting the 123D website is fairly handy. SketchUp, if you have the commercial version, which is not that expensive, is a lovely application for woodshop style making of models. When I say woodshop, I'm talking about things where you cut, where you weld, not organic clay type stuff. If you want to make things that look like Gollum, you want Sculptress. But if you want to make this table, SketchUp is a lovely program, and it's incredibly easy to use. It just costs you a couple $100, etc. Now, here's the problem with this. Every single 3D program out there comes up with its own interface. This is not like word processors, where you can just sit down and, hey, it's a word processor. There's training involved. Every 3D program on the planet is going to need its own training. A lot of your clients are going to say, well, can't I just scan something? Yes, you can. In fact, Autodesk makes some very lovely software that will help you convert your scans into 3D models. Guess what you get from 3D scan? You don't actually get surfaces from most of them. You get what's known as a point cloud, where it just says, there's something there, there's something there, there's something there. Where's the surface? I don't know, you figure it out. That's a non-trivial application, and Autodesk's software that takes a point cloud and turns it into a model is, for commercial versions, I think somewhere around $8,000. Their 123D software is free, and you get what you pay for. You can do 3D scanning with your phone, I assure you. I have done a lot of it. Has it ever worked? No. But if you want models that are guaranteed to work, there are a large number of sites out there to get them. Many of them open source or Creative Commons. Thingiverse is the one that I tend to like because the search utility is actually fairly nice, and it's got a large number of things you can get off of it, such as teeny tiny little, this one is I don't actually have an iPod Nano, but I almost got one just so I could put it in this little teeny tiny Mac Plus. Yes, I'm a nerd. But there are other sites out there. 3D Warehouse is the equivalent for, Thingiverse is operated by MakerBot. So a lot of their files are already formatted to go straight to a MakerBot, and in fact is incorporated into the MakerBot software. But equivalents are available through lots of others. These are the two that we tend to throw students at. If the student just wants, I want a chair for this project, and I can't find the right one, we tell them, well, look at these 3 websites. One of them should have a chair that you can modify. So, I know that doesn't really wrap up with a great bang-up ending. In point of fact, I can go back if you'd prefer. But we have, I believe, 15 minutes for questions. So I am happy to answer any and all questions, demonstrate anything. I didn't bring my puppet, but I can take off a sock and have a little sock puppet conversation if you'd like. But basically, to wrap up with, I guess the bottom line thing is, not a single one of these technologies answers every solution for making a physical object. Resin printers, expensive, most of the time, for at least the ones that we can afford, relatively shatterable, and somewhat expensive. Filament printers, they have that record vinyl surface, and they, the cheap printers only print in the one plastic, and that's also fairly shatterable. You can print in Lego plastic, which, as we all know, is indestructible and magically finds its way to the floor outside your bathroom at 4 o'clock in the morning. And is bloody indestructible. It is a little more, it's not as annoying as nylon, but it is somewhat annoying to print. But the thing is, fused filament, most flexible, can do anything. But getting your model working right is a pain in the butt. Do you have time for that? Does your superior want to fund you to have time for that? Because the one thing that all of these things have, the photolithography printers, the ones where it just go bloop, they smell like you wouldn't believe. And they're relatively high cost, and they have some limitations. In about 2 or 3 years, maybe they'll be better. But right now, do you want to spend $600 to print off, a vase? Or do you want to spend $5 on a vase, but take 2 hours to make it work? So the bottom line here is that when somebody comes to you and says, I want us to get into 3D printing, your response should not be, okay, great, 3D printing. Your response should be, okay, what kind? What do you want to do? Do you want to do the organic stuff that a resin-based printer is really good at, but you never want to touch it? Do you want to do just things that are useful around the home, but you don't care what surface they are? Do you want to do things that are organic and are precisely what you want and as big as they want, and you can slot them right into the machine, like Jay Leno. Jay Leno has a 3D printer that prints metal, and on his expensive car, it's about a $50,000 thing. On his cars, he just scans the engine block or the part or whatever that's broken, fixes it in the 3D software, prints it, puts it right into the machine, the car, and drives off. Literally, he does this. His 3D printer, I believe, not $50,000, $350,000. He's Jay Leno. We are not Jay Leno, thank God. The chin scares me. But that's what, are your bosses wanting to do that? If so, you gotta let them down easy. Because a MakerBot is not going to be able to slot parts that fit right into a car and work. Well, you could if it's like the drink, the cup holder, or a replacement button for your radio, but not in the engine. So honestly, I realize this is not the most bang-up ending for a talk ever, but any questions, any comments? Yes? Do you want the box? I'd love to throw the box. Okay, I apologize if I hit anybody. Oh, aim's off, but hey. I love the box.
Yeah. I've seen the paper, 3D full-color printer, paper printers. Do you have any opinions or experience with those?
No. You mean the foldy stuff?
No, it's called M-Core, and it puts down a flat piece of paper, and it cuts it and colors it as it goes along, and then it layers this paper.
I have, yes and no. I don't have any experience with that particular one, but I have kind of done that with software. Autodesk has a software program that approximates that. It's highly annoying. My fundamental reaction is it's going to be pretty much like, it's just going to be another, it'll take the same files, you'll have to go jump through the same hoops, you have to verify the model, it works, et cetera, et cetera, et cetera. But from what I've seen of that kind of thing, Yeah, it seems to work fine. I think personally, if I was going to do that, well, it's not coming up. Where are you? Where's materials? Here we go. Where are you, you weasels? Here we go. If I was going to do that, I wouldn't buy a printer specifically for it. I'd let somebody else do it, like these guys. There are 3D printing service bureaus out there that will do all the weird stuff. It's just, in my experience, like I bought, for no readily apparent reason, a chocolate printer. I've used it once. So the paper, unless you have some specific application for it, I have no problem saying that if that's the kind of thing you want, it's probably perfectly functional. I just can't think of a reason why I'd want to print in paper, except if I wanted full color. And if I wanted full color, I'd probably go to these guys, because their full color is sandstone and probably is a little bit more durable. These guys print in sandstone for full color. So I'd probably just let the pros do it.
Yeah. What's the name of that place?
This is shapeways.com. This is just, I'm not recommending it. It's just one of many 3D printer service bureaus. This is just the one that I knew had a screen that showed you can print in aluminum or gold or porcelain or plastics or whatever. I just knew these guys existed. There are many others. These guys, there's not a good one. These guys actually ship from New York to where we are. So it's a lot easier for Americans to do it. We're in Canada, but we don't really have a commercial. So these guys are as good as any, but there's others. They just got a cool web page.
Okay. Yeah, it's nice. Looks great.
But I'm sorry for ducking. It's one of those things where, yeah, it works fine. I'm sure it works fine. It's just I can't imagine a need for it. Sorry. Anybody else? Yo.
In terms of the actual printer hardware itself,
What box? There you go.
in terms of the actual printer hardware itself, is there any recommendations that sort of hits the close to the magic area of cost versus what it does? Because basically, if we have a boss that's asking to do 3D printing and they don't really know what they want, and
Then what I would
it's that happy medium of that hits all the boxes. That's easy to use, not $100,000 and works with Macs easily.
Okay. What I would most 3D printers that you're going to work with these days are going to have they're going to be powered by Arduinos in there somewhere. So a lot of them, the one that I use, actually just has a web client. You don't even need. It doesn't care what the file is, so it'll work anywhere. Generally speaking, I hesitate to tell you a particular one to go to, because we just discovered that the carbon printer 5 days ago. And this previous version of this talk was, that technology where the big tub of resin and things pulling out of it, that's going to be 5 years away. And then we discover it actually is now. So things change a lot. Honestly, I would stay away from MakerBot right now, because I kind of suspect that the Stratasys, the company that bought them out, is going to shut them down. I kind of get that feeling. What I would recommend doing is, if you want a 3D printer just to check a box and impress your boss, etc., I would recommend going to the Make magazine. They have very thorough reviews. And just whatever one they currently recommend in the price range that you have is pretty reasonable. There's one that I hesitate to recommend because it is a little bit on the new side. It hasn't actually shipped yet, but it's very low cost. It's called Tiko, T-I-K-O, and its print volume is about yay big, which is cheeseburger sized, but they're planning to sell it for $160. and it's the stuff that they've managed to do with it is pretty reasonable. So if you just want to try it out, one of those would probably be fine, just for experimental purposes. I'm stalling about the other one that I would really look for, but I got it from Make anyway.
Is there one that you use like in your lab?
Yeah, it's called Delta Maker.
Okay.
I don't know if there's the Delta Maker. It's got a huge print platform. It's got a self-leveling bed. It doesn't have what's called a heated bed, which means it'll only print the cheaper lower-end plastics. If you want to do the funky materials, you need what's called a heated bed, because things shrink as they cool, so you want to keep them warm while you're printing the bottom layer, otherwise it gets all terrible and slides around and stuff. So if you want to do the cool thing. So Delta Maker is the one that I use. Ultimaker is probably, they're Dutch. They got a really good reputation. They are the ones that make the biggest print platform, build volume that I can think of. Literally, you can get one of theirs that prints this tall. But other than that, I would just go to the Make reviews and see. You're looking for heated build platform if you want the flexibility, build volume, and Make will also tell you things about how good it is for the kind of application you're likely to do. You want good retract speed if you're doing organic. You want good resolution if you want parts, et cetera. There are some printers that are just going to be finer, capable of going down to 0.1 instead of printing at 0.2, et cetera. But it's really just, what are you interested? If your boss doesn't care, then what do you want to do, and just read the reviews until you say, oh, that looks good, and go with that, because it's moving so fast. I hate to dodge, but yeah. Actually, I think he was.
I'm going to add to the idea of Make Magazine. If anybody's near New York, the Maker Fair at the end of October is a 3D printer festival.
Oh, absolutely. There are Maker Fests everywhere. Any time that you want to look into these things, Google your local area and look for Maker Fair or Maker Fest. Usually it's Maker Fair, F-A-I-R-E. And if you go there and you just say the words 3D printer, all of a sudden you'll be surrounded by a whole bunch of nerds going, here! But yeah.
I was just going to add to that. The Ticos at Delta style, so those tend to do circles much better. So if you want something a little more accurate, do circles. Delta's pretty good.
I'm sorry? Oh. Right. Yeah.
Here it comes.
Yeah.
Thanks. And then I would invest in a good slicer. Almost on any printer, if you could take the same model, the same STL file, the same OBJ file, run it through a variety of slicers, and you can vary 2 hours and your the grain quality that goes with it. So slicing makes a big difference. We use Simplify. Simplify 3D. It's pretty solid. Costs a little money. There's some free ones that are good, but they take a lot more time to.
Yeah, we use Cura. It works, but it's slow, but it works, so we haven't invested. But he's absolutely right. The slice, if it's a commercial printer, you usually want to use their slicer because they get testy if you don't. But in one of the open source ones, absolutely. Simplify, I hear wonderful things about. Yep. Heads up. Okay.
Can you stand up then?
Is there any advantage delta over Cartesian, or is it just the? Can you repeat the question? Any advantage delta over Cartesian? No, I meant the one with the microphone.
Oh, okay. Is mine? Yes, it is working. Oh, wow. Is there any advantage of Delta bots, which is the 3-armed ones that sort of look like truck nuts, versus the XY up and down? Generally speaking, people seem to think that the Delta printers are superior in accuracy over Cartesian pretty much in general. There can be really terrible Delta printers and really good XY printers, but the general thinking is that the Delta printers are superior in accuracy in general, but they are way more pain in the butt to build yourself. So the hobbyists tend, if you want to build one yourself, you tend to go XY. And the Delta style is always going to be taller. It's always going to waste a lot more space. So in my experience, the Delta printers, if you've got a room and you don't really care that it's not going to fit on a shelf, I would get one because I have almost always gotten superior results. That said, I have another printer called the Root 3D, which is an X and Y printer, which, because they built it to have a print head that can go up to 380 degrees Celsius and has a heated print bed, I'll print things on that I would never even be in the same room with my Delta printer, because my Delta printer doesn't have a heated print bed. So honestly, it's one of those things where if you actually have to have the absolute best accuracy, I would look at a Delta just in general, but I'd also read the reviews because there are terrible Delta printers. But in general, the X and Y ones tend to be made not because they're better, but because they're simpler to make. Anyone else? Anyone else? Anyone else? Please? One more. One more. Nope, yes?
Would you buy stock in any of these at this point?
Let's put it this way.
Can you repeat his question?
Oh, absolutely. Would I buy stock in any of these companies? I hate to say it, but no. I would not buy stock in any of them because MakerBot is getting a little crotchety. And the thing is that the field is changing really, really fast. Like there was
This is so cool. It's $500. $600.
Italian company that for $100 they're going to make a resin-based pull it out of the liquid printer for you. So right now I would definitely buy a 3D printer, but I wouldn't buy stock. Because the reason why there's this great big burst of this is because the patents are expiring. So anybody who wants to make a 3D printer, fused filament absolutely can. Anyone who wants to make a resin-based printer, absolutely. There was a guy in Saskatchewan who was making one by dripping water into a tank and having that be his elevation thing. He got ripped off. It was a Kickstarter. But the patent, you can't guarantee that these guys are going to be the ones to succeed because somebody else could take their ideas and run with it because it's all out of patent now. So honestly, you pays your money and you take your chances on what you want to buy as a printer. But I wouldn't risk any money in the stock market. If I was risking money in the stock market right now, it would be on the resin makers and not the printer manufacturers, because the resin is where the cool stuff is happening. A good resin is going to do, I mean, the photo guys, the ones that go bloop, all you need is a bright light and a tank of resin. And so I don't know who makes the best resins right now, but if I was investing, those would be the guys, because they're going to be the ones who have it still under patent and can make money off of it. Well, I hope you guys didn't suffer too much, but it is now 4:30, so